Welcome to another episode of Empower Haps. I'm your host, Leo Dion. Today, I'm joined by Nick Lockwood. Nick, thank you so much for coming on.
Thanks for having me.
It was so awesome to be with you in London at Riverside Swift Conference. I'm a big fan of yours for a long time. Big fan of SwiftFormat. And yeah, you did a great job at your presentation. But before we jump in, I'll let you do your own introduction.
Okay, well, my name's Nick. I'm an iOS developer. I have been for about 15 years now. Prior to that, I was a web dev for a few years. I've mostly worked in companies. I do a little bit of my own sort of side projects as well, and I maintain quite a lot of open source libraries as well, and some tools, including SwiftFormat, as you mentioned.
So before we get started talking about some of the stuff we wanted to, I just wanted to see if you had any thoughts about the conference and like how has it maybe changed your perspective on Swift and where things are headed.
Yeah, I really enjoyed the conference, actually. I wasn't really sure what to expect beforehand. I've never been to a sort of server-side Swift conference before.
Same here.
And yeah, obviously, like my main focus is app development, predominantly iOS development. So I wasn't sure how relevant it would be, but it was really interesting. And I think the sort of the real buried lead was the presence of so many Apple people there as well. Like the opportunity to meet and talk to like folks who actually work on Swift and Apple tooling.
And I've been to a few conferences, but I think this is the first one where I've seen a lot of Apple people, and also like Apple actually sponsors it. Besides some of the other companies, and of course Tim's company as well. But yeah, I mean, they're like actively involved and actively interested. And it was almost, I was telling people, especially the talks from Ben and Tony at the beginning were very much like mini dub talks in a lot of ways, especially the announcement of Java interop was really cool.
Yeah, it absolutely had that feel to it. And, the fact that they were there in an official capacity as well, not just kind of like, hiding in the crowd and being anonymous.
Right. It's like, so you have a gradient from like marketing Apple stuff to like developer geeky Apple stuff. And at the very top, you might have like the like announcement of a new Apple TV show. And then you have a little bit more is like an announcement of a certain Apple product. And then you get a little bit more, and you have like the WWDC keynote, and then a little bit geekier is the State of the Union. And this is like the last level of like geekiness. Apple announcements is like Java interop. And I was trying to think what other talks there were, but just like for instance, Fran's talk on the with pattern with async await. It's like even more, it's like way down the geeky level of Apple talks and announcements. So that was very cool. At least I enjoyed it a lot. So, and it was great to see them there.
Yeah, couldn't agree more.
So should we start by talking about linting, or do you want to talk about your talk at the conference?
I guess we can talk a little bit about the talk. So, I mean, because, I was presenting to what I was aware was a server-side Swift audience, and of course, like my area of expertise is really not that. Like, I tried to keep it as general as possible, and I mean, it seemed to go down pretty well. But yeah, generally the topic of the talk was Swift specifically, rather than necessarily like mobile development or app development with Swift.
I think everybody in that audience learned something new from your talk. It was pretty hilarious, all the little ins and outs. I'm just trying to think of what I picked up on. I mean, I knew a lot of it. Like, the fact that there's like two ways of doing an initializer with an optional. Like, I knew optional was an enum. I didn't know that if you say that, it changes the format of the generated init, which I thought was really interesting. And then, I don't know, there were a lot of like odds and ends. I knew that you could do a lot with labels, but I'm always scared of labels because I always feel like they're kind of antiquated.
Yeah, it's got a sort of go-to feel to it, right?
Yeah, exactly.
I think that is, I mean, it's like when I first encountered labels, they were in fact a substitute for GoTo. Like I'm a super old school developer. Like I started with BBC Basic, where like every line was numbered, and you'd go to like line 10 or whatever, and then if you inserted more code, you had to renumber everything. So I think I first encountered labels when upgrading to like Visual Basic, and it was like, there's no line numbers, but how do you go to? And like that was the answer, right? So yeah, I was a little surprised that labels are still around, but they are quite useful, and the way that they're used in Swift is very structured. So you can't like break out of a function or something crazy and like end up somewhere.
Right.
It is still sort of following structured programming principles. It's just sometimes it gives you that little bit of extra flexibility when it's break, but break from where? There's so many options.
That was actually really helpful. Yeah, I remember that from your talk. That was really interesting. Because I hadn't thought of that, like break from. So does that work with like continue, I guess, or would it even be applicable to continue?
Yeah, okay. Break, continue, like all of the kind of like loop sort of terminating commands work that way.
Of the things that you talked about, what was the one thing that you're like, people should know about it? And what was the one thing that you say people should not know about it?
About the talk or about Swift?
About Swift.
Oh gosh, I mean, there was a few things in there which are kind of the form. It's really cool that you can do this, but please don't. Like like these little tricks were.
Do you remember one of them?
I'm trying to remember now. I think the thing with the optionals, so the fact that you can, depending on whether you use optional shorthand or like the longhand form, I have used it, but like whenever I use it, I put a big fat comment above it saying, this is why I'm doing this, because it's not intuitive, right, at all. And like, I mean, even so, SwiftFormat has like a rule that will turn like one type of optional into the other. And, if you start like actually treating these as having a difference in your code, it's easily the kind of thing that somebody will just come along and say, oh, that's not our coding convention. I'll just switch it to the other one, and then maybe have some unexpected side effect. So like, it is dangerous to play with things like this. And actually, I caught up with one of the Apple engineers, and they were laughing about this because they were saying like, I don't think that was intentional. Like this wasn't like it just happens to be this way. Like they didn't design it that way. It was somebody forgot to like like update a code path or something. Otherwise, they'd have both worked the same way all along, most likely. So it's sort of relying on a bug.
I would almost go with like the question mark because that's the preferred way in the syntactic sugar way. And then if you want a custom in it, then just create a custom init that forces you to like.
Yeah, for sure. I mean, I think one of the things I've run into with Swift is that you're really spoiled by all the code gen that it does for you. And like having to, you unfortunately get these kind of like sort of points where you just want to do some little thing. You just want to do some little bit of customization, and now you have to rewrite everything yourself. So it's like
Codable is a classic example.
Codable is, and in fact, this is kind of related to that. So like, sort of default initializers are something where it's like, you either write nothing at all, or suddenly you want it to be public, and now you have to write like 50 lines of initializer, and then you have to keep that in sync and update it forevermore every time you add a property from now on. Codable, I really hate writing like manual codable implementations, not because they're particularly difficult to write or understand, but just because.
But if it's like one field, then you're like, what the hell? Like
exactly. And now I've just said all of these other ones, And plus, you look at one of these custom implementations, and you really have to like look at it. So like, what is this doing that's different from the standard one? And you find like just somewhere buried in deep among 100 properties is like, like an optional sort of, handling it just in that one little special case, just very slightly differently from the default. And it's annoying.
And so then you just create a macro and spend 3 weeks trying to write a macro for it.
Right. Well, I mean, I think we'll get to that conversation later, but yeah, for sure. I mean, this is what leads to all kinds of craziness, where like people want to avoid having to write the boilerplate, so they do something that only they can understand.
Programmers love to automate, even if it means it takes them longer.
Yeah, I think there's an old joke like, why write in 5 minutes what you could spend like 3 days automating.
Okay, so I want to talk about the future of linting. How much of a headache is it to maintain SwiftFormat with the fact that the language, and that's kind of what we want to talk about today, is how much the language has changed over the years. Like how much of a challenge is that? Because if you looked at the stuff today, like one thing we'll talk about later is type throws. I've been really into type throws lately. And like, that's a big change. And then you got async wait and actors and all that, and non-isolate and all that stuff.
That's a really good question, and actually, it's funny because like Swift format's quite an old tool. Like I think I started work on it in 2016, something like that. So
Okay.
it's like it's coming up on a decade old, and I I actually did like a podcast with somebody like a couple of years after I created it, where I told them like it was basically finished. Like I considered it to be in sort of maintenance mode, and I was done with this because like there's only so much you can add to a formatter, right? And like it wasn't like the language was changing that much. And I think the pace of development of Swift has actually really accelerated in the last few years. Like it felt like Swift was pretty stable for a long time between sort of like the 3 to 5
Yep.
version era. I don't think an awful lot changed, and maintaining Swift format during that time was pretty like low effort. It was pretty low maintenance, and since like async away, it's just been an explosion of new functionality, like new keywords in every release, like new things to think about. And I mean, this is a great thing. Like, I'm actually super happy that the language is evolving and there's cool new stuff to play with. But it certainly has made my job a little bit harder. I think maintaining Swift format, there's kind of two pieces to it. One is making sure it doesn't break things. Like, if somebody starts using a new language feature and Swift format doesn't understand it, it will do something ranging from like not understanding and maybe throwing an error to potentially like corrupting your code in some subtle way. And that's
Yeah.
like really bad. And I don't want it to do that. And I try and keep on top of that as much as possible. Ideally, even like having it updated to support new functionality before it's out of beta, so that like people will never actually see this problem in the wild. But there's a second level of support for features, which is like with these new features comes new expectations in terms of like formatting. So Swift's format's thing is that it's not just a formatter; it's kind of opinionated, and I try and have an opinion about. Like when there's multiple ways to do things, I try and have an opinion about which is the best way or which is a good way, and I try and like add format rules that will enforce that so that code bases can be kept consistent. That's kind of the point of the tool. And I mean, where necessary, I'll make it configurable because not everybody will agree about the best way, but like usually people will have an opinion on what the best way is, and I try and let them automate that rather than having to kind of like do it manually. So.
Right.
Yes, there's a lot of stuff that's been added to the language where I haven't yet really had time to form an opinion about like what to do about this. So things like typed throws. Should I be writing a rule that will convert untyped throws to typed throws? Is that even feasible? Like I don't know. Like I haven't had time to look into that yet. What I have had time to do is make sure that if you use typed throws, then it's not going to break your code. And I think that's kind of the bare minimum.
So yeah, I think kind of what's the future, I guess, of Swift format? Are you intending to support all the new stuff and maintain it? Is there some point where you're just like handing it off? I remember you also saying that you don't even use Swift syntax underneath, right? You're using your own Lex parser type thing, correct?
That's true. I mean, Swift format actually predates Swift syntax by a few years. So when I released Swift format, Swift lint already existed. People often confuse these, but they're entirely unrelated projects.
That's Realms.
That's Realm, yep. And Swift lint was using something called Source Kitten, which was a wrapper
That's
that
right.
JP Simard wrote around Source Kit, which of course is like the underlying sort of compiler for Swift. It's actually much more powerful than Swift syntax. It can do things which Swift syntax can't do and which Swift format can't do, because it actually understands the full structure of your project. So there are rules in Swift lint for things like like removing unused imports, I think, and stuff like inserting self and things like that, which I have a version of in Swift format, but
Okay.
it's not complete because everything that I do is basically lexical. Like I just look at what's happening in the current file, and like I can only apply rules that have that level of understanding. I don't, for example, know the types of variables. If things are defined in another file, I have no idea what they are. So there are limits to what I can do, and switching over to Swift syntax wouldn't actually help solve that, which is why I've not had like a great deal of compulsion to do so, because it would be a huge refactor, a huge rewrite. And it's not exactly clear what it would give me. It would potentially, reduce the effort of like updating to support new features in the Swift language. but it also comes with some burdens. For one thing, it's a huge dependency. And
I was going to say that, yes.
Currently,
as
I have no
anybody who's written a
dependencies.
macro, you learn that quickly how, it's
Well,
massive.
exactly. So yeah, it's a massive thing. It would increase compile times and so on. And I need a good reason to switch over to it. The other thing is that Swift syntax is version specific. Like it's built for a specific version of Swift. And one of the nice things about having my own parser is that I can relatively easily support all versions of Swift, or at least most versions of Swift, with just a single code base, which is not. It doesn't seem to be an active goal of Swift syntax. So I don't anticipate that they'll be doing that.
Right.
And so yeah, it has given me a lot of flexibility that I can release a version of SwiftFormat that supports everything back to Swift 3 up to unreleased versions of Swift with features that are still in development. And people can just have the one version of the tool. They don't have to install the correct version for their tool chain or whatever.
So have you looked at Apple's alternative Swift format? And what's kind of your opinion on, obviously,
yes, I mean,
Swift syntax? So that's a lot of fun to have to get going. But
of course, I'm aware of it, and I mean, I've monitored it since it was its inception. So there was in fact a Swift dash syntax in the code base, kind of unmaintained and barely functional when I wrote Swift format, and I assumed it wasn't kind of going anywhere, and for many years that assumption was true. And then, suddenly at some point, post Swift syntax, I think it was actually a Google engineer whose name escapes me temporarily, basically said, "Hey, we should build a formatter on this," and submitted that as a tool to Apple, and they accepted it, and it became part of their standard set of stuff. And even then, it was several years before it kind of really went anywhere. Finally, now it's being included with Xcode as a thing that you can actually invoke with a key combo. And so maybe every year I'm thinking maybe this will be the year that Swift format is Sherlocked for real. So yeah, arguably maybe this is the year. Maybe it's finally happened now that Swift format in Swift dash format is official. Maybe that's it. Maybe it's time to start winding down the project. My thinking at the moment is when most people get Sherlocked by Apple, you make an assessment and you're like, do I add value above what Apple is doing?
There you go.
And
exactly.
Is that value sufficient to be worth the effort of maintaining this, right? Because a lot of the time, unfortunately, it's sadly the case that people will use the worst thing just because it's more convenient, right? Or it's more standard, or it's more out of the box.
Right.
And I think the Apple community is especially like this. Everybody jumped on Combine and forgot about RX Swift, and the RX Swift people were like, no, this only does 10% of the stuff that we, but nobody cares, right? Because it's the standard Apple thing, so it's this is what we use now. Right. So there is an element of that. I'm sure that's the case. It's also super confusing now because now that Swift dash format is a real thing, but it's called Swift format. I get people giving me support requests, and I'm like, no, actually, this isn't my tool. This is Apple's one, or vice versa. People post about Swift format on social media, and I'm not sure whether they're talking about my tool or Apple's. There's all kinds of confusion there, and it's it's bad enough.
Did you put a little thing in the README now where it's
it hasn't quite. I actually can't remember if I have something there or not. I remember I used to have this confusion with Swift Lint, which isn't even the same, but people will be like, "Oh, right. I saw your tool got mentioned." I was like, "No, that was Swift Lint." Yeah. But it's fine. It's fine. I think basically what I'm going to do is wait and see. I'm still working on Swift format. A bunch of people are still using it, and I don't want to give them I don't want to give them a painful migration path. And also it aspires to do some things which I don't think Apple's Swift format will ever try and do. Like I said, it's an opinionated tool. I'm deliberately I have rules in there that might break things. It's kind of 90% okay, but 10% risk. And I'm pretty sure Apple will never do things like that. But a lot of people like to use those things. So
what? I think what's an example?
Well, as I mentioned, because I'm not compiling your project and I don't look at anything other than the file that I'm formatting, I have to make certain assumptions, and some of them are very safe assumptions, and some of them are less safe. So some examples are, for example, I remove self, removing self, implicit self is a very common thing. It's a rule that's on by default, but there are certain cases where it's not actually safe to do. So one example would be
closures, anything with async await, yeah.
So it's auto closure specifically. So closures, it's
Okay.
fine. Like I can infer whether it's safe to do there. Like and the rule is not dumb. It works out everything that it possibly can.
Right,
So
right.
yeah, it knows that if you use self inside a closure, it's because you have to use self inside closure. But if you've got an auto closure at the call site, it doesn't look any different. Like it just looks like you're passing a parameter. But the
Right.
rule about requiring self is still there. So the type system knows that self is needed, but there is nothing in the syntax to tell you that it's needed. And because I don't often, I mean, I potentially, if the function was defined in the same file, I could look it up, but chances are it's defined in a different file, and so I have no way of knowing what the type is there. And so I just
Right.
remove self anyway. There's a mechanism where you can like register functions that you know should have self, like things like logging functions are typically like where people use this, and some of the standard logging stuff I've kind of like coded in as being like, oh yeah, this is this requires self, and then you can add your own to that list if you want to use the rule without having to like put exceptions at every single place where you use it. But it's things like that, right? And so I don't anticipate that Apple's Swift format will ever have a self removal tool, because it's not actually possible for them to implement it reliably using Swift syntax, which is the technology that they're using.
So I was just looking at it. So Apple has 2.5 or 2,500 stars, and you have almost 8,000 stars. So that's pretty good. That's a pretty good indication of where things are right now. I guess it'd be interesting to see how it changes over time.
Yeah, I mean, I think they probably got their 2,000 stars a lot quicker than I got my first 2,000. So, I suspect they're on a sharper gradient than I am. But yeah, we'll see.
That's true.
We'll see how long before they intersect and overtake.
I think one of the good points you've made is like the thing about linting is consistency. I'm a big fan of linting because one of the things I want to look at when I go through my Git history is not white space changes and like whether somebody decided to go from tabs to spaces or spaces to tabs. Like for me, if I can keep my code as consistent as possible and just insert changes that are specifically functional as opposed to styling or like formatting, then that's where like linting is really takes a big advantage. That, and I think just like stuff like making sure you have comments and certain like documentation comments and things like that are always helpful. But it's like always, that's why I'm a big fan of linting and Swift formats both and Swift lint, because I just want to make sure every time I put something in my repo or I do a merge request, it's always going to be consistent with whatever. And it's clear to me when I look at the history, I can see what changes are actually functional changes.
Yeah, absolutely. I mean, it eliminates noise, and it also eliminates like wasted time during code reviews or whatever, where it's like, if you have a coding style, it would be preferable if people didn't have to like manually enforce that, sort of like, oh no, you didn't use like this, whatever. So yeah, it's much better if there's just a tool that can do that for you.
Yeah, right. Especially white space. Yeah. One of the things I like, I don't know if your Swift format does it, but I know Swift lint does it. And it's really weird. But like even the order of functions, I try to keep those consistent. And I know like Relp's tool, what it'll do, and I'm weird, but like it'll tell me, oh, like you should put properties first and it second and functions and so on last. And like that's really helpful to me because like I said, like then the noise isn't there because like the function, it's like purely functional changes whenever I make commits to history and stuff. And then that way everything is properly formatted in the correct order all the time. But
yeah, there is some support for that, for like code organization. It's kind of opinionated because this was actually contributed by Airbnb, who are big contributors and actually sponsors of Swift format. So a lot of the rules in there are kind of just like, this is how Airbnb likes to do it, and if you like that, then turn it on. But that's not on by default. It's something where I guess I'm not actually that strongly opinionated about like the correct order for these things. And
I'm not opinionated about the correct order, but I want it consistent. Like I guess that's my thing. It's like it's not my preference to how I do it, but like at least it's consistent every time, and like then the deltas are just easier to read.
Yeah, that makes sense. I mean, I think the difference between Swift format and maybe a tool like Prettier is that it's not a complete formatter. So Swift is just too complex. There's just too much to have an opinion about everything. Like, I don't think there is a canonical way to like format Swift code down to like the level of every character. So I do the best I can, but it's generally like making a bunch of surgical changes to the code rather than just like taking it down to the AST and like fully formatting everything from scratch. And maybe that's a stretch goal. Maybe one day we'll have that, but I have the feeling that like it's not really possible with Swift. Like there's just too much variation in the way that people like to do things, and there's just too many things where it's just really not clear what the right approach is there. But as much as possible, yeah, I completely agree with you. Like it's preferable if there's just one agreed upon way to do things in a code base, maybe not universally, but in any given code base, it's better just not to have to think about that.
Right, exactly, 100%. So one of the things I wanted to talk about with you is like, we've kind of talked about it, and this has especially been the case over the last year since I'd say like maybe like 5 to 6 or 5 to 5.5, once we started introducing async await, and some of the stuff with like types, sum and any, and all that kind of stuff. It's there's a lot of challenges, it would seem, for a newcomer to be able to pick up Swift now that there's a lot of these new pieces that we've added. What have you seen? I mean, I don't know how many new employees or new software developers you've run into, but as far as like learning Swift as the programming language has changed, and like how the design of the language has changed.
You mean in terms of like being accessible to beginners?
Yes. Yeah, exactly.
It's a really good question, and it's one that I feel like I'm not really qualified to answer because I kind of, I grew up with Swift, like I was there from the beginning. And so a lot of the things that it does that are weird, I feel like I don't notice because, it's just always been that way. And you kind of get like acclimatized to it. My feeling is, I mean, like Swift's bold claim is that because of this principle of progressive disclosure, it's an easy language to like learn. And maybe harder to master, but it's you should be able to like just dive straight in, not worry about the things you don't need to worry about yet. Like write basic code, and it should be simple and easy to understand. And I think there is a lot of truth in that. I mean, people keep saying, oh, Swift's the new C++. It's got all these complicated, weird features in it. It's like, but okay, yeah, sure. But how often do you actually run into those things in your day to day? Like, have you ever seen, consumable or whatever? Like, have you ever encountered these keywords in code that you didn't like deliberately like put it there? It's just not. It's not at the forefront of the language, right? It's not like the first thing you encounter. When you're trying to write hello world, you don't have to worry about whether like your variable is being consumed or not, or whether it's async. Like you don't hit these things. So I do think that the language is quite approachable. And you have things like Swift Playgrounds where, I mean, maybe if the sort of editor was a little bit more stable, I think it would actually be quite easy for novice programmers to use.
Right.
The language is it's just sort of simple looking. It's deceptive. Like it's not actually that simple, but it looks simple. And for doing simple things, I think it is pretty simple. The fact that it keeps memory management and stuff out of the way and so on. I think there is a danger to the sort of veneer of simplicity that, particularly with Swift UI, I think Swift UI enters into the realm of being so much more complicated than it actually looks, that it's very easy to shoot yourself in the foot. I mean, even as I like to think, experienced developer, I often find with Swift UI that I'll make some minor typo or something, and I'll be sitting there for 10 minutes thinking, why isn't this running? And I'll realize that I've done something that has just hung the compiler because the type confusion that I've given it is so great that it has no idea how to even tell me what was wrong. And like things like that are real sharp edges because I have no idea what a person who's like not confident about coding would do in that situation. Like, because what most of the time what I have to do is just like undo back to like the last stable point, because the chances of me being able to diagnose the missing bracket in like a sort of like 100-line Swift UI body is basically zero. Things like that really feel like maybe they've kind of gone a little bit too fast. Like they've added functionality without like the sort of debugging story really being able to keep up with it. Things like async await don't bother me particularly, but again, now that they've introduced all of like the strict concurrency, we're getting into stuff where I'm seeing very, very experienced programmers throwing up their hands and going, okay, I just don't know what I'm supposed to do here. Like, I tried to turn on like strict concurrency, and it just like, yeah, I just had to give up, right? And that doesn't seem good. Like, if experienced programmers are having this issue, I have no idea what a sort of novice is supposed to do in this situation. I mean, obviously, what they're supposed to do is not turn on strict concurrency. But if this is the future of the language, at some point, presumably, we'll get to a point where it's not optional anymore, and everybody's expected to have it. And
right.
I don't know what happens then.
So I think a lot of it, like the stuff you're talking about SwiftUI, what I've found is like type inference kind of gets in the way of getting things to work, because it will try its hardest to figure out what you're doing and think that you're doing it correctly. Like, I had an instance where I was adding like a toolbar button or something, and it was like, all I did is change a method, so then the method call was invalid, but I didn't realize that, and it was like obviously giving me an error, like that's misleading, which is what happens with us 90% of the time. It's like I definitely did something wrong, but the error was like a red herring because it was trying to do type inference and thinking, oh, like the SwiftUI view is incorrect, and it's like, no, the SwiftUI view is perfectly fine. It's some function I was calling that doesn't exist. But it like took me, like you said, I had to do undo, and figure it out. But yeah,
exactly, because Swift strong typing is such a useful tool. Like when you're coding along and you change the signature of a method, and it just tells you everywhere, oh hey, you need to add this extra parameter. You learn to rely on that so much when you're coding, and then in the middle of like a SwiftUI body, doing that means that instead of it saying, oh hey, you missed this parameter, instead it's going like, wait, I have no idea what this thing is. I have no idea what any of this thing is. Like you've got this kind of like explosion of type inference failure, where it goes from like fully understanding everything to understanding nothing at all and just not being able to help in any way. It can't even tell you where the error was because it doesn't even know what it's dealing with anymore.
I mean, that's where they should invest in AI, is like Xcode error messages. Like I know GitHub has a thing lately where it's like explain error using Copilot or something, and I'm like, that's because I've been using the latest Mac OS and the latest Xcode, so I've been using the new code completion stuff in Xcode, and it's been okay. But like that to me is like where you should be investing, is like error handling and like knowing the proper error that is actually going on based on the like millions of developers who run into this all the time.
Yeah, I mean, I'm a little skeptical of these technologies. Like, I haven't used Copilot in anger, I'll admit. But the problem is, the problem with the sort of the hallucination effect is like,
when it's very strong with SwiftUI, right? Because SwiftUI is fairly new. Right.
Exactly. This is the problem, right? So like when it's a well-established problem, sure, it'll give you a great answer, and like it can be amazingly like good at explaining things. But if you're like, the second or third person to ever have encountered this problem, if only it could just say like, sorry, dude, I don't know. But instead, it's always going to be like, it'll be a very cogent, very coherent explanation that is total nonsense. Like,
exactly.
And then again, like, for the novice developer who's like relying on this to tell them what to do, like it's just making it worse, right?
Right. Because there's just so little test data out there that it's been trained on. It's like you try to pull up like Bash scripts, and it's amazing. You try to pull up SwiftUI async await stuff, you're kind of screwed. The one tip I would have, so a couple of tips I would have is A, like break your SwiftUI stuff into smaller pieces, and B, like actually say what type things are. Be very explicit, because that's a good way of like seeing, because that's what it is. It's like when you start doing the type inference, it tries its very best. But once you start being very explicit about what each type is, you do colon int or colon whatever foo every single place you can. That's a good way to find out what the actual error is, and then it doesn't have to try its hardest to do type inference.
Yeah, absolutely. I mean, I think it is a problem with the language. Like, there's no two ways about it. Like, I really like type inference. I like the aesthetics of type inference. Like, it makes it nicer to write the code. But I just don't think they should let you infer types in situations where the compiler can't deal with it like this, right? Like, the rules have clearly been made too lenient. The tools are not capable of supporting the level of like type inference that they're offering us.
Right.
And if they had just been a little bit stricter about this and just said, look, you have to specify the type here, we could work it out, but like the trade-off is not worth it.
Or just like, all you have to do is in the IDE just put something in that says, explicit type, and then you just have to fill in the little template thing, and like now you at least are heading somewhere.
Yeah, absolutely.
Yeah.
I mean, I think
part
it
of
could
the
definitely be
problem,
solved with tooling.
part of the problem is when Swift was introduced, people were pissed about how much like types don't just like work like they did in Objective-C. So like I feel like it's a part of that is the fact that like in Objective-C it didn't matter if you used an int or a double or a whatever type. It just could do the pointer conversion for you automatically, and like people were pissed that like in Swift you have to be very explicit about like converting your number or your string or whatever it is into the right type. You know what I mean?
I think part of the problem with Swift's type system is that, like, most of the time it's great, it's really easy, simple to understand, like, a string is a string, a number is a number, or whatever. But you do get these weird cases where, like, if you're doing something like, I don't know, some functional programming where you're doing like a lazy map of something, like, have you ever looked at those types? They're insane. Like, the type will be like some like sort of, it'll be like 100 characters worth of type with like multiple nested generics in it. There's no way you're going to type that. Like, nobody would ever want to type
right?
that.
Some kind of tries to do that,
Yeah.
right?
It's some solves part of that problem, but I think it only. It's actually something I always bump into. It's like, oh, I've got this horrible type. I'll use some. Oh, wait, that only works for protocols, right? Like, it only works for some protocol.
Right.
It doesn't work for some like generic type. So yeah, unfortunately, that's not. It's not a complete solution. But yeah, this is the thing. Like, with strong types comes like ludicrous types, and when if you look at the actual types of Swift UI bodies with something that's got like 10 subviews in it or whatever, like there's no possible way they can expect you to explicitly type that.
Do the refactor in Xcode, and Xcode like actually literally types out the type, and you're like, dude, come on, just do some.
Like, I'm not putting that in my code base.
Right.
So yeah, I don't know what the right solution is. I mean, I have some theories about it, but I mean, we could probably talk about language design forever. But I generally prefer the sort of TypeScript approach where it's the typing is sort of optional. So like maybe during development you just don't need the types, and then maybe at production time you put them in. Whereas Swift's approach is you always have to have the types, and it tries to make it easier by doing type inference. But you end up with the worst of both worlds in some ways, because it means you're having to think about types during your development process when you don't want to, and then also you're leaving out type information, which then has to be inferred in your like final build, which means your compiles will be forever slower just because you didn't type in the type. So like I don't think it's necessarily the right trade-off the way that they've done it. I know enough about how it works to understand like there are good reasons why it works the way that it works, but as a development experience, it's maybe not optimal.
Did you have any other comments about programming language design when it comes to any of the new stuff?
I think Swift is now kind of feeling its age in terms of like when you set out to design a language, it's all truth and beauty, and like everything's terribly elegant. And there's some things about Swift that are so beautiful, like the way that they handled mutability with structs and copy and write and everything like that. It's so seamless and so lovely. And like there's no other language I've ever seen that handles this whole like mutable structs thing the way that Swift handles it, like so elegantly. Where if the struct is a var, then all its properties are var. Like this kind of thing is really, really nice. Like I looked into Kotlin, which is like superficially very similar to Swift, and it's nothing like as nice. Like the way they have to like make mutable copies of all of their arrays everywhere, it's just not in the same league. But then I first started seeing like the cracks appearing in Swift when they had this thing with slices, like array slices and substrings. Yeah. Whereas like you remember they made this change originally, like a string was a string was a string, and then they were like, actually, there's a difference between like a string and a string slice, and we're going to have to make this explicit. And it was like, this doesn't feel nice anymore. Like I get a range of a string, and then I try and assign it to a string, and it's not the same type, and I have to explicitly cast it. And I kind of felt it was a little bit downhill from there. So yeah, it's like I almost feel like Swift is like it's over a decade old now. Like maybe it's time for like Swift 2, where they can like reset everything and do it all nicely. Of course they won't. I mean, like there's no possibility, but. It does feel now a little bit like it's not the shiny new like beautiful language anymore. It's acquiring cruft that can't ever really be removed, and it's sad. It's inevitable, but it's sad. It would be nice if some of the kind of early mistakes could be rectified in a way that didn't require them to maintain source compatibility. But I don't
Were
see
you
a way
the
to
one
happen.
who had the talk about why strings don't have indexes, like just a simple index for character?
Yes,
Okay.
that was also me.
We'll obviously put that your talk, but like that was really interesting. Do you think it's a good argument to not have indexes because it makes it look easier than it is?
That was essentially my argument. I mean, so it does have indexes, but the indexes aren't integer indexes, basically.
Right.
And the reason for that is because computing the difference between indexes is a big O of n operation. So basically, the longer the distance, the longer it takes.
I mean, do you think that's a
not the
good
case.
thing in API design to be explicit about, hey, we're going to make this look awful because it actually is awful underneath?
I mean, it's a compromise for sure. I mean, so to turn that around, it is a very bad thing to have attractive nuisances in your API design. Like, you do not want to have an API that looks like it's simple and straightforward and will be quick and is actually like a foot gun. So I think they are right to avoid that. I think it would have been nice if they had put more effort into like making it easy to do the thing that you want to do and making it clear how to do the thing that you want to do. Because I think the problem with the Swift string design, API design, is there is probably a right way of doing things. It's different from the C way, which is arguably the obvious way. And it's not very clearly signposted like what you're supposed to do. So people reach for integer indexes, they don't find them. So then they try and work with the indexes that there are, and they're horrible to work with. And then they're like, this is horrible. And what they should actually be doing is something completely different, but it's not easy to find the thing that they should be doing instead. It's like not an obvious refactor from the code that they started with.
Yeah, totally, 100%.
Maybe more work could be done there.
Yeah, totally. I get where you're coming from. Yeah. There was something else I wanted to mention that you brought up. I'm trying to remember what it was. You talked about strings API design. Oh gosh, I can't remember what it was, but it was like you were mentioning just like about how, Swift feeling its age. I mean, so to me, like async await was always the last thing it had to do. Do you feel like there's more that they need to add to the language that is missing?
Yeah, I mean, it's not even like, Apple is quite happy to tell you like the things that they're missing. So there's this thing, I can't remember what it's called now, with generics basically. Like the generic story is not complete in Swift yet. So there's certain kinds of like generic coding that you can't do. They've made a lot of progress there with, I think there's parameter packs and generic parameter packs and so on, but it's still not possible.
Parameter packs are broken, by the way. Like,
oh yeah?
I try to do some fancy stuff with parameter packs, and it's like an actual bug in Swift. So
interesting.
Yeah, you can only get so far with it.
Features, I guess. Yeah.
Yeah.
So there's a lot of stuff around that, and I think again this comes back to my point before about how I sort of prefer the TypeScript approach. So like, with Objective-C and with TypeScript, there's a bunch of things that the type system can't really represent, but you can still do them. It just lets you do it. It just can't really statically enforce that you've done it right. So it's basically like, the failure mode in languages like
Are you suggesting we should just have any for everything? Just put any in any
No,
object?
not at all. But
okay.
What I am saying is that in Objective-C you can do that, right? And it doesn't hassle you and it doesn't force you to like put typecasting everywhere. It basically just says, if you're going to use ID for every type, I can't help you. Like the compiler cannot help you. You will fail at runtime. That's on you. But I like to have that as a get out, like as an escape hatch, right? Now with Swift, you can't do that because like the semantics of any are not the same. So of course you can use any for every variable type, but you will have to cast it to the thing you want it to be everywhere you pass it. Right. With Objective-C, it works the other way around. It says ID means turn off type checking. Just like let it go, catch it at runtime. And I think that's a nice balance because it means that you can write like anything that can be statically type checked, you are welcome to statically type check. Anything that can't be statically type checked because the type system isn't sophisticated enough, you can have a go. If you know what you're doing, it'll work. In Swift, if the type system can't represent it, you're not allowed to do it. Like, there are perfectly valid programs that Swift will not let you write because its type system is not sophisticated enough to handle that yet. One day it might be sophisticated enough, but right now it isn't. And that means that we're limited in what we can do with the language until the compiler developers have figured out a way of representing this, which is the opposite approach.
I think I know what you're talking about, but do you have like a specific like instance of something you can't do in Swift because of this?
So something that you now can do, but for a long time you couldn't, is if you had a protocol with associated types, a PAT, you couldn't have an array of those, right? You couldn't have an array of like equatable, for example, or codable, because there was no way of like saying this thing conforms to a protocol, and here's an array of things that conform to this protocol.
And you're talking about an array of different different equitables.
Heterogeneous, like
heterogeneous.
Exactly.
And that's what any tries to do.
So any has solved this problem, but we had to wait a long time for any, right? Like any wasn't until some late version of so like a decade. So for a decade we couldn't do that. We couldn't have an array of, and so you had this weird compromise where it's like, I'd really like to add an associated type to this protocol, but if I do that, it's going to break all of my code, and there is no way around it. The only way around it would be to use any, like literally any, for the array of types, and then you're into like totally untype checked like weeds, right? So this is my point. Like, in something like TypeScript, you'd be able to do this and it would be fine, because it would the type checking would just check as much as it could and no further. Right. And that's okay. And protocols in Objective-C work in a similar, not protocols, generics in Objective-C work in a similar way. They'll check what they can check, and if they can't check, it's fine. Just do it anyway.
Right.
And that's what I'm saying, like, is maybe more optimal from a developer experience. Like, the type system in Swift, often, if you try and do something like this, you can spend a lot of time, like, scratching your head saying, how can I represent this? Like, is there some way that I can trick the type system into letting me do this? Like, I know it's legitimate. I know what I'm doing, but it just won't let me do it because I can't explain to the compiler what I'm trying to do. And like, sometimes you just realize there's no way of doing it, and you just have to give up and come up with a different approach.
I mean, macros kind of tries to do that, where it basically will like create the type for you that you're trying to create. Like, you can kind of get away with it with macros, but of course macros are a pain in the butt, so that's not easy.
Yeah. I mean, again, macros are a thing that I think I wanted in Swift for a long time, and then when they finally came, like that wasn't really what I wanted. It's kind of thanks, I hate it.
Thanks, I hate it.
I think. Sorry, no, you carry on.
I was just gonna say, have you looked at like type throws at all?
I have, and type throws again is something that I've wanted for a long time. And
so the one big limitation I've run into is rethrows. It like doesn't know how to do rethrows, and that makes him like, I try to use him now wherever I can, but anytime I have to do like I want to do a rethrow, then it's like you can't do type throws anymore.
That's interesting. I thought that there was, because the rethrows keyword I think is now kind of deprecated, because supposedly type throws had a better solution for this, but off the top of my head I can't remember what that solution was supposed to be. But I thought you were supposed to be able to do that. Okay,
yeah. Once you do a rethrow, it like doesn't. It just basically you lose the type essentially.
Yes.
It becomes
so
I
think what you're supposed to do is like make the calling function generic on the throwing function's throws or something like that. I could look it up, but I can't tell you off the top of my head. If you look in the original Swift evolution proposal for typed throws, I think this is covered specifically as a case. But the bigger problem I had with typed throws, which comes down to another like language feature that I dearly wish that Swift would have, but the like maintainers are like absolutely like dead set against ever adding this, and so like probably it will never happen. But basically, so you have this situation where you've got a function which throws two different types of error, right? So you need the if you want to maintain typed throws, the outer function has to throw like a union of those two error types. It could be one or the other, and there's not really a good way of doing this in Swift.
Right.
TypeScript, again, I know I keep talking about TypeScript. I don't even use TypeScript. I'm like a fan from a distance, right?
Are you a fan of TypeScript? Do you think it's better than Swift?
Well, so I don't... I mean, for many reasons, it's not better than Swift.
Okay, I was going to say...
I'm not a heavy enough user to actually judge whether it's better in any way, really. But there are things I like about like the design of the type system in particular. And the thing that I like most is the way that they've handled type unions. So in Swift we have enums, and enums can be used as a kind of type union because you can have like different cases can have different associated like values of different types in them.
Right.
But that's not the right tool for a situation where you've got like, function like A throws error type A and function B throws error type B. And so function C that wraps those needs to throw error type A or B.
Right.
You'd have to create like a new type of error, which was an enum that can wrap A or B, and then you'd have to do all the wrapping yourself manually, and it's like a load of like extra boilerplate, and it's a horrible way of doing it.
I think you're wrong. I think you should write a macro that creates the enum for you, and then you could refer to that enum that's created by the macro. I think that's what you should be working on next.
We can debate what the right way of doing this in Swift is, given the constraints of Swift as the language stands at the moment.
I'm being totally sarcastic.
But the way that TypeScript would do this is you just say that this throws A or B, right?
Right.
Which is the obvious right way of doing it. And that way of doing type unions is like it's useful in many contexts. Like another place where Swift's type system totally lets you down is JSON. So like when you parse JSON, it gives you a dictionary.
Yeah, that's a big one.
And anything in that dictionary can be like, it can be a number, it can be a string, it can be like a Boolean, whatever. Like it can be an array of any of those things. And what type does Swift give you? It gives you any, because there is no way of representing that type in Swift, right? And the obvious way you would represent it would be a type which is a union of int or string or number or whatever. And that could be strongly typed. It would only let you use those types. You couldn't throw like, I don't know, an image in there and expect it to work.
They would tell you that that's what enums are for, right? I mean, they're kind of like enumerations and they're unions in a lot of ways.
Sure, but they didn't use enums. Why didn't they use an enum? Because the ergonomics of it are horrible for that. That's why they didn't. It's not actually the right tool for that job. And so claiming that it is, but then not using it for that job is kind of like telling on themselves.
I mean, you kind of need like a computed enum, right? Like that's the way you get around it. Or
absolutely.
or like, I know I was being sarcastic, but they should just have a built-in macro that does that for you. And
maybe that's the approach they'll eventually take with this, because they don't want to add type unions. But I wish they'd just add type unions. Like, it would be so nice. This is the strength of type. Like, it's not so much like they're nice in the JSON case, but that's not the killer case. The killer case is where you're composing these unions like on the fly for cases like error handling, where you don't want to have to define them all in advance.
Right. No, I get it.
So yeah, that's the one kind of like thorn in typed throws for me. And this was actually part of the justification for why they didn't have typed throws originally, was like this was one of the reasons. It was like pretty soon if you're throwing, like you're going to lose track of what the type is actually supposed to be, and you don't want to have to like change the types throughout your whole system just because you've added like an extra case somewhere deep in it. So they've added typed throws, but they've not fixed the reason why they didn't add typed throws in the first place. Right. And I do feel like this solution is like just sitting there ready to be like implemented, but they're not going to do it.
I mean, I'm glad we have type throws than not having type throws, even if
absolutely
it's
it was a huge. I mean, it was
because you had to do a result every time, and I hated it. And it's like
I was quite like I was like an avid follower of the evolution proposal for result when it was originally added, and this was one of the killer use cases for it. Like the other one, which is now kind of obsolete, was because like at the time we didn't have async await, so you were using closure callbacks for handling like maybe a network response, and you really wanted it to give you a result, not like an optional error and optional data or whatever, which was a horrible like ergonomic thing. So they result solved that problem, but it also did give us like a glimpse at what a world where typed throws was possible would be like, because it gave us strongly typed errors. And
have you done anything with non-copyable? Have you dabbled into it at all?
It doesn't feel like a tool that is much like sort of consumable and borrowing and all of these kind of things. It's not something I reach for very often. Like I think it definitely it will have a lot of interesting use cases, but probably they'll mostly be in sort of like fairly low level library code. I don't think it's something you're going to use much in an app. I mean, I've seen some clever stuff that people have done with it.
My gut feeling is that it's like it's a way of. I think you've hit it right on the nose. I think it's like basically like files, stuff that like literally
file handles is a clear case. Yeah, but the point is that you should really only be using once.
Do you think they want to get rid of classes in a way?
This is an interesting question. No, I mean, so.
And what I mean by that is like either it has to be thread safe and be an actor, or it has to be a struct. And if it has to be a struct and it can't be copied, then make it non-copyable. Do you know what I mean?
Yeah, for sure. I mean, classes are a bit of a weird thing in Swift because they cover many different roles that sort of don't feel like they should be coupled together. Like, one of the reasons classes exist is because Objective-C compatibility was obviously a requirement.
100%. Yeah.
So if you take that away, it's like, does the language need classes? I mean, it almost feels like I tried, I always feel like I'm letting myself down when I have to use a class. Like, it's always like, it's the last choice, right? Your first choice is a struct or an enum, and like, if you have to use a class, fine, you'll use a class, but you're not going to feel good about it. And the thing is, though, that there's no such thing as like a ref. Like, there's no naked reference in Swift. We've got like in-out for passing by reference to a function, but you can't just have like an in-out property, right? So sometimes, if you've got something like a linked list or something like that, and you need a back reference, like you have to use a class. There's no other way of doing it. And I often run into these situations where it's really frustrating because the tooling around structs is so nice and the tooling around classes is like so poor by comparison. My model is like a struct and it's like self-serializable, self-codable, self-equatable, like all of that synthesized for me. My initializer is synthesized for me. And then I suddenly realize that I need to be able to have like a shared reference to this, so like my view model can like mutate the shared model or whatever. And it's like, wait, if I turn this into a class, it ruins everything. Like now I have to write my equatable implementation. I have to write like all of this has to be done manually, and it's horrible. And like probably the nicer solution is to like wrap the struct in a class and just have like the property exposed. But then you've got this weird API where like you've got this level of nesting that you don't want. And what I really want is the language to just let me say like by ref my struct or something like that, but it doesn't let you do it. So, I mean, maybe they want to get rid of classes, but like, there's a long way to go before we can. I think. Like,
sure. I think the backwards compatibility is a big part of that story, right?
Even setting that aside, like there is no alternative. Like for when you really have to have like shared mutable state or whatever, there is no alternative right now in the language. And sometimes you do, unfortunately. And I think again with Swift UI and stuff, and like publishers and all these kind of things, like if anything, the usage for that has gone up. Swift data is all about classes. Like they're not getting rid of them. If anything, they're doubling down on use cases for them.
Yeah, fair enough. Have you seen this recent proposal for vectors?
I have. Yes, long overdue. I have.
Okay, tell me the story behind. Tell me the story behind it. And first of all, how pissed you are that it's called vector when you're into 3D graphics.
Yeah, fair. Okay, so there's a few different things there. So first of all, what is it? Well, basically, it gives you fixed size arrays. So there is no way of doing fixed size arrays in Swift right now. If you import a fixed size array from C, because in C all arrays are fixed size effectively, unless they live on unless it's a pointer to an array, it gives you a tuple, which is like a crazy thing, like because you can't do anything with a tuple, right? Like you can't index it, you can't like get the nth item.
That drives me nuts. UUIDs, the UUID type underneath is like tuple of 16 bytes, and it's like, why would you do that? Yeah.
So it's a horrible thing, and it's long overdue for them to solve this. Like it was kind of the absolute bare minimum. Like, oh, what's the closest type we can map this to in Swift? I guess we'll use a tuple, and then like they never came back to it. So yeah, it's basically useless. Like if you're trying to work with C APIs that actually give you fixed size arrays, it's hopeless. So vector is like the correct type for this now, and it required them to do some infrastructure stuff. I can't remember what it was now, but they had to. There were some pieces missing before they could implement this. But when they added those pieces, like they even said at the time, like we're basically doing this because now we can have fixed size arrays, and now we have them. So the name is an interesting choice. Like as you mentioned, like I'm a 3D graphics person, so like you might think that I was annoyed by the name, but actually I think I'm okay with it because in fact it is literally a vector. Like, if you have a fixed size array of like doubles or something, like that is the type you would want to use for a 3D graphics vector. Like, you'd want an array of 3 doubles or whatever, and vector is the perfect name for it. I mean, it would probably annoy me because then now what do I call my type? But we always have this issue in Swift.
So like I think I saw the big use case is essentially for what do you call it, for like embedded Swift because of the memory constraints.
That's true, but I mean generally any high performance code, and particularly like stuff like graphics code, is going to be like excited about having this feature.
Okay.
Like Because the big problem with Swift for performance, like writing performant code in Swift, and embedded code is performant code almost by definition because it's usually very resource constrained. So the big problem with Swift is it loves to allocate without telling you. Like, there's no way to say, don't allocate, please. Don't put stuff on the heap. Like, it'll just do it all the time.
It's the same thing with actors and threads, right? It's like you have no clue. It abstracts all that away from you.
Yeah, exactly. There's a lot of abstraction going on, and it's really, really hard to get Swift not to allocate. Like, there's a lot of things which don't require allocation in C, where there is no way, or there's certainly no idiomatic way of doing it in Swift without involving heap allocations. And arrays were one of the big ones.
And so a vector is a vector. I have to use this term. A vector is mutable, but you cannot change the size. Is that correct?
That's correct. Yes.
Okay.
I mean, I think the mutability is like struct, like it's kind of opt-in mutability. It also has like opt-in copyability and all of these things, right?
Right. But basically, like, you can change the values, but you can't change the size, essentially.
Yeah. So it's like an array in every sense, except that the size is fixed. But it has the same value semantics as an array. Like, you can pass it around, you can make it immutable or mutable.
So Ade, who had a really great talk at Server-Side Swift, he had a question on Twitter about macros that I want to close out with. He wanted to know if there would be any macro you would want to build.
So I would reference Daniel Steinberg's very excellent talk on this subject, which is like macros are not for you. Like macros are they're for Apple to build like infrastructure more easily. That's how I see them. The fact that we are able to write our own macros is a sort of accident of the design of the Swift language, that they wanted to make sure that the standard library in Swift is all written in Swift. It's all dog fooding itself. There's no magic secret behavior going on behind the scenes, or as little as possible. As much as possible, they want like the language runtime and everything to be written in the language using standard language features. And macros are another piece of that. Macros allow them to implement, sort of special functions and useful things using like a standard built-in feature of the language without having to go in and edit the C++ code of the compiler, which I think they probably hate doing as much as we would. But I don't think macros are intended. You shouldn't be writing like a bunch of macros in your app. Like your app shouldn't define like 10 new macros and write a bunch of code using macros. It's just a way of obfuscating your code. It's the same with custom operators, right? Like when Swift came out, it's like, oh, you can write your own operators, and everybody's writing loads of operators. And like no sensible code base does that really. Like maybe it'll have like one, or maybe you'll like define a plus operator that also works on vectors or whatever. But like creating loads of custom macros is just a way of obfuscating your code. And I think it's the same with macros. And unlike sort of custom operators or property wrappers or any of these other things, macros also come with a huge overhead in terms of just like, compile time and just the general effort of building them, which is why like they're not a tool that I would reach for. Like it would be very much the last resort. Like I'd probably even go to like third-party code gen tools like Sorcery before I would use a macro, because they're that unergonomic to use like in an actual code base.
Yeah. No, I totally get where you're coming from. 100%. Was there anything else you want to talk about? What did you want to mention about 3D graphics before we close out?
I don't know if I had anything in particular that I wanted to talk about with that. I mean, it's an area of interest for me. So it's like if it's something you wanted to chat about, like that's a thing I can chat about. But I don't know that I necessarily. I noticed you mentioned like the Vision Pro. I don't have strong opinions about that. There's some interesting stuff about like the fact that they've basically killed SceneKit now, but I don't know. I don't know if that's worth
maybe
the time.
We'll have to have you on again to talk about it once you spend was it $3,000 on a Vision Pro, or I don't even know how much they are now. Is it $1,005?
I think it's at least that. Like they're expensive, but I guess there'll be like a Vision Pro Mini for people with small heads and lower budgets.
Smaller heads and lower budgets. The women's size, right? Like the watch bands.
Yeah.
Nick, we'll have to have you on to talk about that. Thank you so much for coming. This has been fantastic. I'm really glad we finally got you on.
Yeah, I really enjoyed it. Thanks for having me again.
Where can people find you online?
So I mean, I have a presence on Twitter, or X as we're supposed to call it now, but I tend not to hang out there because it seems to be full of Nazis. So I'm mostly on Mastodon these days. I think that's the best place to find me. Or, if you want to like talk about my GitHub projects, then probably GitHub is the logical place to start that conversation.
We'll put links to that in the show notes. Thank you again, Nick. It's fantastic. People can find me on Twitter at LeoGDion, Mastodon at LeoGDion at c.im. BrightDigital.com is my company. If you are interested in coming on the show, or you are looking for help with anything, just feel free to reach out to me. If you're watching this on YouTube, please like and subscribe, post a review in your podcast app. Thank you, everybody. I look forward to talking to you again. Bye.